We're talking today about line plots. Now, you probably remember working with line plots last year. But what a line plot is, it is a graph and it shows the spread of data using X's above a number line. You probably remember marking X's above a number line last year. Now, the X's show the number of times the value occurs in a set of data. Now, let's look at this example and watch me plot the data points on this line. Now, you'll notice they chose to use eighths down here on the number line. Probably the reason they did is if you look at the data, most of the fractions have a denominator of 8. If it doesn't have a denominator of 8, then you need to rename that fraction. For instance, 3/4. I can use 8 as my denominator. We're going to divide down, multiply up. 4, we're going to 8 two times. 2 times 3 is 6. So I have now renamed 3/4 to 6/8. And by the way, normally I would use a pencil with math. I would never use a pen. I'm using a pen today so that it will stand out in the work that I do. I see 1 and 1/8, 1 and 7/8, 1 and 1/8 again. Here is 1 whole, 1 and 1/4. I want to change the fourths to eighths. Bring my keepers down. My 1, my fraction bar, we're going to use 8 as my denominator. 4, we're going to 8 two times. And remember, I put the little tiny 2 there. Then 2 times 1 is 2. 1 and 1/8 is good. 7/8, there's 1 whole. 1 and 1/4, I need to rename that to eighths. Bring my 1 down. 8 is my denominator. 4, we're going to 8 two times. 2 times 1 is 2. And then 1 and 1/8. Now I'm going to plot these points. It'll be easy now because all of my denominators are eighths, just like down here. Now, I guess I need to read what the experiment is. It says, for an experiment, Elena planted some bean plants. She measured the height in inches of each of the plants after 1 week. Here are the results. So here are the heights of her plants. Now, after we get common denominators, I'm going to make a line plot down here. We've got the common denominators of eighths. Now, I'm not plotting 3/4. I'm going to plot 6/8. I'll come to 6/8 and I'll put an X there saying that it happened once. 1 and 1/8, right there. All right, 1 whole. Which fraction down here would be 1 whole? I hope you said 8/8. There's our 1 whole. 7/8. Notice how I'm putting an X every time it occurs. 1 and 1/8. See, that gets another X. 1 whole again. 1 and 1/4. I can't plot that. I'm going to plot it as 1 and 2/8. 1 and 1/8. 7/8. 1 whole again. 1 and 1/4. That's 1 and 2/8. And 1 and 1/8. Now, let me count my fractions. I should have that many X's down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Something's wrong. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's what it was. Sorry, I miscounted the first time. You'll see me make mistakes and you'll be wanting to tell me and you can't because you're not here with me, and I'm sorry. Now, this tells me that there was one bean plant that was 6/8 inches. Oh, they're using inches. Okay, it was 6/8 inches. There were two bean plants that were 7/8 inches. There were three bean plants that were 1 inch. There were four bean plants that were 1 1/8 inch. And there were two bean plants that were 1 2/8 inches. That's what a line plot does. And then we could answer questions about this line plot. Now, you don't have this in front of you. I'm going to do another sheet for you to practice with me. If you don't have this sheet, just use notebook paper. But this was just a way for me to introduce what a line plot is. So I'm going to put my practice sheet for you right here, and we're going to look just a minute at this. Now, let me bring it in a little closer for you. Now, I'm going to focus it. It's going to get blurry for just a second. There, that's better. Okay, we're going to work on the line plots on this page. All right, it says, complete the line plot for the given set of data. Let's look at number 1. Amount of pecans in bags. We've got 3/8 pounds, a half pound, 3/4, 1/8, and so on. They've started the line plot here. They gave it a title. They said the amount of pecans in bags, and they're saying they're doing it in pounds. Now, they made a number line down here and they used eighths. Why do you think they chose eighths? Look at the denominators up here. That is one denominator that they all have in common. I see 8, I see 2, and I see 4. If I get a common denominator with those, it would all be 8 because 2 and 4 would go into 8. So since they used eighths, if it's not an eighth up here, I'm going to rename it. So 3/8 is okay. 1/2, I need to make that eighths. So I'll bring my fraction bar down, put an 8 there. I'm going to divide down, multiply up. 2 are going to 8 4 times. Then 4 times 1 is 4. So I just changed 1/2 to 4/8. 3/4 I'll change. 4 we're going to 8 2 times. 2 times 3 is 6. So now it's 6/8. 1/8 is good. 3/8 is good. There's a half. And I've already done a half. We called a half 4/8 here, so it'll be 4/8 here also. 5/8, 1/4. I haven't done that one yet. 4 we're going to 8 2 times. Excuse my hand being in the way. Then 2 times 1 is 2. 1/2, there that is again. It's 4/8. Oops, look at me. 4/8. 5/8, 7/8, and then 3/4. I did that one right here. It was 6/8. So that's 6/8. So now I've renamed all of the fractions, and all of them are eighths. All of my fractions are eighths. Now I'm going to plot these on the number line. Now you'll notice, here's 3/8. I'm going to find 3/8 right here, and I'll put an X there to plot it. Now 1/2, I changed it to 4/8, so I need to plot it as 4/8. 3/4, 6/8. So I'll plot it as 6/8. Remember, you want to use the same denominators. 1/8, I'll plot it as 1/8. 3/8, put another X there. 1/2 will be 4/8, put an X. 5/8, plot it there. 1/4 will be 2/8. 1/2 will be 4/8. 5/8 I'll plot. 7/8. 3/4 will be 6/8. Now this one, it shows me the amount of pecans in bags. So 1/8 of a pound, that happened once. 2/8 of a pound happened once. 3/8 of a pound happened twice. 4/8 of a pound happened 3 times. 5/8 of a pound happened 2 times. 6/8 of a pound happened twice, and 7/8 of a pound happened once. So that's how I plot. Now remember, you want to make sure that when you add up your data, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I've got 12 data points, then you want 12 X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now this says use the line plot from question 1 for questions 2 through 4. Now, by the way, if at any time I get too far ahead of you, pause your video so you can catch up. I know I'm going a little faster than normal, but just pause the video. Now look, the total number of bags of pecans. How many bags of pecans were there? We knew there were 12 different bags because we counted our data points and we counted our X's. So that would be 12. Now it says the total weight of all the bags that have 3/4 pound of pecans. So I want the total that had 3/4 of a pound of pecans. Well, 3/4 is not on here, but what fraction up here equal 3/4? Oh, it was the 6/8. So how many 6/8 did I have? See, we know that equaled 3/4. There were 2, and it's asking me what was the total weight of all those bags. If there were 2 of them that equaled 6, I know they equaled 6/8 each, but they're using 3/4, so I'm going to make them 3/4. So I would say 3/4 plus 3/4. I'm getting the total of all the bags that had 3/4. There were 2 X's above the fraction that was equivalent to 3/4. So I'm going to add that, and look what I get. I don't have to change my denominator. I'm good to go. I get 6/4. Now, we know that's improper, so I've got to divide to fix that. 4 will go into 6 one time. 1 times 4 is 4. Subtract 2. Stop and rock around the clock. That's 1 2/4. And we know that that equals 1 1/2 if you put that in simplest form. So the total weight of all the bags that have 3/4 pound of pecans is 1 1/2 pounds. Let's look at number 4. We'll still be using this data to help us. It says there are blank more bags that have 1/2 pound of pecans than bags that have 1/4 pound of pecans. Well, how many had 1/2 pound? How many bags had, and that, by the way, there are blank more bags. So evidently we're going to be comparing, and when we compare, we have to subtract. So let's see, how many had 1/2 pound? Let's look up here at our data. Which number equaled 1/2? That was 4/8, right? So a 4/8, that was 3. A 1/4 pound, let's see which one. Oh, that was 2/8. So on 2/8, there was 1 X. So says there are blank more bags that have 1/2 pound. So there's 3 that have 1/2 pound and only 1 that has 1/4 pound. So what I would do is subtract these. 3 minus 1 is 2. So there are 2 more bags that have 1/2 pound. And if you look, there's the 1/2 pound. And the 1/4 pound is the 2/8. Look, there's 3, there's 1. I would say 3 minus 1, and that would be 2. All right, now we're through looking at the pecans. Now we're going to come down here and look at ribbons. If you have any questions now, don't forget you can reach out to me and I'll try to help you as best I can. Now look at the length of ribbons. Notice the denominators. They were all measured in yards. We want to get all our denominators the same so that we can plot them on the same line. They used sixths, so that's what we will use. We will use sixths also. So looking at the sixths, let's see, this one will need to be renamed. I'll bring down my keepers, bring down my whole number. 2 we're going to 6 3 times. 3 times 1 is 3. So 1.5 will change to 1 3/6. Here's another 1.5. I can call it 1 3/6. Here's another 1/2. I can call it 1 3/6. Okay, I think that's it. All right, 1 1/3. Bring down my 1, put my 6. 3 going to 6 2 times. 2 times 1 is 2. So this will be 1 2/6. 1 2/6. I'm changing all my 1 1/3 to 1 2/6. Now let's see, this one's good, that's good. The 1 yard, that's going to be my 1 whole. We should be able to plot that. And there's 1 1/6. So now I'm ready to plot my data. They've got the title, length of ribbons in yards. Now 5/6. Oh, wait, I don't want to do that. I want to go in order up here. 1 3/6, put an X. 1 2/6, I'll put an X. 5/6, 1 2/6, 1 1/6, 1 3/6, 1 1/3, which will be 1 2/6, 1 3/6, 1 whole, we know that would be the 6/6, 1 2/6, and then 1 1/6. Now, we're going to take these questions and look at this data to answer them. Now, this says on number 6, there are blank pieces of ribbon that are 1 1/3 yards long. See, they're referring back to the original fraction, and we change 1 1/3 to 1 2/6. So here's my 1 2/6. How many X's do you see? There are 4. So there are 4 pieces of ribbon that are 1 1/3 yards long. Now look at number 7. The total length of the pieces of ribbon that are 1 1/6 yards long. Now they're wanting the total. All right, 1 1/6. They're using 6 here, so we're good. There were 2 ribbons that were that length. If they want the total, that means I'm going to add. So that would be 1 1/6 plus 1 1/6. I've got the same denominator, so I'm good to go. So my answer, add my whole numbers. 2, keep my same denominator. 2 2/6. And I would need to put this in simplest form, just like I did up here. Remember, you can do factor trees. 2 is prime. 6, 2 3 prime. Stack them. I have a match there. Remember, if I don't have anything left up top, it's understood to be a 1. So 1/3. So 2/6 will become 1/3. And I'll keep my 2. Don't forget that whole number. So the total length would be 2 1/3 yards. Now, looking at the back. This is talking about the time spent practicing the piano. Here's their line plot over here. We've got our data points. Looks like our denominators are going to be easy. They've got 4 and 2, and they used 4. So any denominator over here that has a 2, we need to rename it. So let's call it, we've got to have a title. Time spent practicing, I got to write smaller, don't I? Practicing piano. And it's measured in hours. Now, look at my data points. Since they use fourths, I want to change all of mine that have a 2 as a denominator to fourths. Let's see, 1, put my 4 here. 2 are going to 4 2 times. 2 times 1 is 2. There's a half. So 2 are going to 4 2 times. 2 times 1 is 2. Fourths, we're good there. Oh, there's 1 1/2. Oh, and I used 1 1/2 there. So that's 1 2 fourths. Okay, and here's 1 2 fourths again. Now I'm going to mark my data points. And what you may want to do is you pause the video, do it yourself, and then replay it to see if your answers match mine. Okay, 1 1/4 goes here. 3 fourths here. 1 1/2, which is 1 2 fourths here. 1 whole hour. They gave us 1 whole here. That was easy. A half hour, which is 2 fourths. 3 fourths. 1 1/4. 1 1/2, which is going to be 1 2 fourths. See why it's important to go ahead and rename them? 1 1/4. 3 fourths. And 1 2 fourths for 1 1/2. Now, so all we're doing with this one is plotting the points, just practicing. Count your data, remember. 1 2 3 4 5 6 7 8 9 10 11. Count my X's. 1 2 3 4 5 6 7 8 9 10 11. Now, you can tell that 1 1/4 and 1 2 fourths, there was a tie. So, and they also tied with 3 fourths. So that's how you can use your data. It spreads it out. All right, let's move on. Sorry to be moving so fast, but remember, you can pause it if needed. We're going to use this line plot for questions 9 and 10. It's about shelves, the lengths of shelves, and they did the lengths in yards. And they've already got the line plot made for you. And what you're going to do is answer these questions based on the data. Now look at number 9. It says, which length did the greatest number of shelves have? Remember, these were my lengths. So 1 shelf was 1 1/6 yards. 3 shelves were 1 2/6 yards. 2 shelves were 1 3/6 yards. 5 shelves were 1 4/6 yards. 4 shelves were 1 5/6 yards. And for 2 yards, I didn't have any shelves that measured that length. Now it's asking me, which length did the greatest number of shelves have? Look at the X's. The tallest row would be the greatest number. And all of those had 1 4/6, yards. So that would be the answer for C, 1 4/6. All right, coming over to number 10. It says, how many shelves were longer than 1 1/3? Well, now if I look up here, I don't see 1 1/3. So that means I've got to put these in simplest form to find out which fraction equaled 1 1/3. 1 1/6 we know is already in simplest form. Let's look at 2 6. 2 is prime. 6, 2 and 3, prime. If I stack them, 2 on top, 2/3 on the bottom, look what we got. There's a 1 that goes there. Remember, it's understood. So there's my 1/3. So this would equal 1 1/3 also. So they're saying how many shelves were longer than 1 1/3? Well, 3 shelves were 1 1/3. Everything on this side was longer than this. So I would include all of these shelves. These are all longer than 1 1/3 yards. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my answer would be C. There were 11 shelves that were longer than 1 1/3. Now you might would have to come and put all of these in simplest form to see which one actually equaled 1 1/3. And the reason I knew to do simplest form is because 3 is less than all of these. So that means they put these fractions into smaller pieces. And remember, it's in simplest form if it gets in smaller pieces. All right, our final problem says write a real world problem about cups of sugar using the data in the line plot. Now I'm going to help you out here. The title of it is The Sugar, and it's measured in cups. And it says 2 containers had 1/4 cup. 4 containers had 2/4 cups, which we also know that to be a half. 3 containers had 3/4 cup, and 1 container had 1 whole cup. Now, if I had to write a problem, I could ask how many cups were more than half full. How many cups were more than half full? So I've got to look down here. Which one of these is equivalent to a half? That's right, 2/4. So more than, I want everything after this one. So if you look at the after this one would be all of these. How many X's are after the 1/2? 1, 2, 3, 4. So the answer would be 4. Now, if you have any questions about this lesson, let me know. I'll be glad to help you. I can send you some extra practice if needed. Thanks for watching.